So the last thing we're going to do in this section is talk about the squeeze theorem. So I'm going to state it if h of x is less than or equal to f of x, g of x for all x greater than or equal to some c, where c is constant, is a constant, then the limit, and I know that the limit as x goes to infinity of h of x equals L. That's the same as the limit as x goes to infinity of g of x. Then the limit as x goes to infinity of f of x is also going to be L. So basically, if your function f is squeezed between these two other functions, h of x and g of x, and if h and g have the same limit, then this function f has no choice. It has to have the same limit as well because it's squeezed between these two other functions. So it kind of has to go along with what the other two functions are doing. So let's look at an example involving some limits. So the first one, let's say I want to look at the limit as x goes to infinity of sine of x. Well, if you remember the graph of sine, I'll kind of sketch it real fast. It goes up and down and it repeats, right? Up and down. That's a really rough sketch, but it follows this repetitive pattern. And so as x gets larger, your y values are cycling up and down. So this limit does not exist. Let's look at this other limit now. Let's look at the limit as x goes to infinity of sine of x over x. So, well, I know that sine, the largest value is 1, and the smallest value is -1. So sine of x is between -1 and 1 for every value of x. Now, if x is positive, I can take and divide by x, and it won't change my inequality. And so what I've done is I've squeezed my function between these other two functions, and so I'm going to look at the limit of those two functions. If I look at the limit of -1 over x, it's 0. Same thing for the limit as x goes to infinity of 1 over x, it's also 0. So then the squeeze theorem tells me that my function, sine of x over x, has to have the same limit. So I'll say by the squeeze theorem, the limit as x goes to infinity of sine of x over x, this is going to be 0. And I do want to end with one more example. This one doesn't involve the squeeze theorem, but I want to mention find each limit. So if I'm looking at the limit as x goes to infinity of x cubed, if you plug in large values of x, you'll see that this limit is going to be infinity. And if you look at the limit as x goes to -infinity, x cubed, well, if you plug in really small negative numbers like -100, you'll see this limit is -infinity. Another way you could see these limits is by graphing the function y equals x cubed, and you could see what happens to my function as x gets larger and as x gets smaller.